Okay, hi. So my name is Richard Wilkinson. I'm a senior lecturer in the Maths department at the University of Sheffield. And I'm leading this part of the module, which is on a brief introduction to statistics. So the aim of this part of the course is to equip you with knowledge of some of the main ideas in statistics and that you're going to come across in statistical analyses. And our aim is to give you a high-level understanding of these concepts rather than a mathematical understanding of the nitty-gritty of how to do things. So our aim is to equip you with enough knowledge so that when you have a problem of your own, you know what kind of statistical analysis might be appropriate, and you know enough to be able to go away and read about the kind of analysis that you might want to do. So we're going to deliver this part of the module by what's called flipped learning. So if you've not taken a flipped lecture course before, it's just like a standard lecture course, but the lecture and homework elements are reversed. So every week we're going to make 5 or 6 short videos, about 10 minutes each video, available to you on YouTube. And then you'll have to watch these videos in your own time at home. And after watching the videos, we're going to give you a short quiz with fairly easy questions. That's going to add up to 15% of the total assessment for the module. Then in the lecture slots, rather than you sitting there and listening to the lecturer talk, we're going to give you some exercises. We're going to hold the classes in computer labs, and you're going to work through the exercises, doing some analysis on some real data sets. And there's going to be lots of helpers. So we've got 3 PhD students and the lecturer all going to wander around talking to you, helping you out with the statistical analyses, which we're going to do on that lab. So there's going to be some of those exercises that you perhaps don't have time to finish during the labs, and so you're going to finish them in your own time and then submit the work for assessment, and that's going to add up to another 35% of the total. So in this first week, we're just going to look at some fairly basic concepts. So we're going to start off by looking at plotting, essentially, which we often get called exploratory data analysis. So whenever you get given a new data set, you should always begin by plotting it. They say a picture's worth 1,000 words, and a good plot can really help illustrate the story that this data is telling. So we're going to look at different types of plots, from things like histograms to box and whisker plots, scatter plots to show correlations, and so on. So by doing different types of plots and highlighting different information in the data, we can hope to kind of gain an understanding of how we might want to analyse the data, what the data is telling us, and what kind of statistical model will be appropriate. The next concept we're going to think about is that of sampling variation, or randomness, if you like, in data. Whenever we measure anything, there's always uncertainty associated with it, and that's particularly true when we are only measuring a small sample of the total population. So imagine a situation where there's a large population of individuals, maybe everyone in the UK, and we're interested in measuring something about these individuals. So here I've got them spaced in X and Y space, so maybe they've got 2 measurements for each one. Okay, and suppose we want to know something about the average of the population. Now this is just a toy example, so I've made it up. But let's suppose that for the population here, the true average is 10.3. Now, in our study, let's imagine that we can't afford to measure whatever it is we want to measure for every individual in the population. All we can afford is to measure something from a small sample from this population. So what we might do is choose a small number of individuals to measure. In other words, we take a sample from the population. So all I've done here is I've randomly selected about 20 individuals, and they're the ones coloured in red. And I've measured the information on them. So that's giving me data which I've called x1 to xn, where n's about 20 here. And we compute the average for this sample, so that's often called x bar. It's just the sum of all the measurements you've taken divided by the total number. And that here gives me a sample mean of 11.4. So we can use this sample average to estimate the average of the entire population. The idea of sampling variation is that if we did this again, if I took another sample, I'd get a different answer. So this is a different sample of 20% of the population. And this time I found a sample mean of 10.3, which is different from 11.4. And it just so happens in this case to be the same as the population mean of 10.3. But if I do it again, It's a different selection of 20%. I get a sample mean of 11.2. Do it again. I get a sample mean of 9.1. Do it again, and I get 10.3 again, etc. Okay. So you get the idea that by sampling repeatedly, we get a different answer each time. Now, normally, of course, we can only afford to take one sample. So a lot of statistics is understanding how the numbers we measure would vary if we were to measure them multiple times. Or in other words, another way of thinking about this is what's the error on these numbers? Okay? What should our error bars be? Now in this case, we can imagine sampling from this population a large number of times, okay? Taking a sample of 20 individuals over and over again, and we'd get a range of different values. So we know that the sample mean for the entire population was 10.3, which is where this red line is. But if we take a sample of size 20, okay, we can get values as small as 6 or as large as 14. But overall, the samples we take will have averages clustered around the population sample, which is about 10.3. And we can think about how variable these things are by thinking about the range of values we expect to see, what's a 95% confidence interval. But we'll get to this in later videos. So the final concept we're going to see in this first week is all about the idea of a distribution. So the aim of statistics is to learn about the world and to make inferences in situations where there is uncertainty or randomness. So in order to learn, we need data and information, okay? But we also need to make assumptions. Those assumptions are usually in the form of a model for the data. For random quantities, we usually model the distribution. So the distribution of a random variable describes how the variable varies if we were to see multiple instances of it. So in the previous slides, we've looked at the mean of a sample. Okay? We might only have one mean, but we can think about how that number would vary if we were to collect it multiple times. And so that's what we're doing with modelling. We may only have one instance of a quantity, but we might model it by some particular distribution where that distribution describes how we think it would vary if we were to see it multiple times. We should also make a note here about what random means. Okay, so random can mean that the quantity is genuinely random, like a coin toss, or it can sometimes mean that it's simply unknown. Okay, so let's consider these different random variables here. So X could be, for example, the number of Labour MPs in 2020. Okay, so that's a random quantity that we don't know what it is, but we can think about a different distribution for it. So we know it could be at most 650, which would be every MP, and it could be the smallest it could be with 0, and it's got to be a whole number. Or a different random variable would be X, which is the number of goals scored by Chelsea in their game on Saturday. Yeah, so again, it's got to be a whole number, 0 or greater, okay, and it's very unlikely that it's going to be a value bigger than 10, but it's possible. Or another example would be the number of people in the UK with cancer. So this last one is an example of a quantity that's not random, okay? It's a fixed number. Yeah? There is a definite number of people in the UK who currently have cancer. It's just that we don't know that number. Okay? So we're going to model it as a random variable and try and infer it. And so what we'll do in this first week and some of the later videos is look at some common distributions that can be used to model random quantities. Things like Poisson distribution, or a binomial distribution, or a Gaussian or normal distribution. Okay, so remember, we're putting all the material for this part of the module on Mole. And in particular, you need to get to the statistics section of the Mole page, which you can get to from the navigation bar on the left-hand side. Just click on the Statistics Resources link. And under there, you'll find a folder for each week of the statistics part of the course, labelled by which week we're in. So this first week is week 7. In there, you'll find a link to the YouTube playlist, and we've embedded all the videos as well, so it's clear which videos you need to watch each week. But after the videos, there'll be a short quiz with a small number of questions that you need to take. And remember that these questions count towards your final assessment, okay? So try and answer them as well as you can. There's also a copy of the slides we've used to produce the video, and for this first week in particular, there's some MATLAB commands that we've looked at, so we've given you a copy of the M files, the MATLAB files. So in later weeks there'll be less of an emphasis on the MATLAB and more on the ideas, but because this first week is about concepts you've seen before, like plotting, we wanted just to really emphasise how you do things in MATLAB, so this first week is a little MATLAB heavy. Finally, there is a section, a folder where you need to submit your completed worksheets once you've gone away and finished them off in your own time after the lab sessions.